We're going to continue our discussion of 8.6 here with some word problems. The first kind of word problem is a weighted average. That's just a way that when you find the average, some of the numbers carry more weight or importance than others. And that's actually how the grade in the class is calculated. Now, you can do this with your own percentages on PowerSchool. If you go on PowerSchool, it should be able to tell you what your percentage for quizzes are, what your percentage for tests, and your percentage for assignments. Now, since we haven't taken the final, it's not actually calculating in the final. So these percentages don't exactly match right now the syllabus. These percentages down below are what the syllabus indicates, and once we take the final, that is what PowerSchool will actually go back and fix to. So I just have an example student here. They have a 93% on quizzes, an 84% on tests, and a 95% on the assignments. So we're going to calculate out what that person's grade is in PowerSchool using weighted averages, which is how, again, your grade is calculated. To do that, you need to take the percentage that you currently have, and you are going to multiply that by the decimal equivalent of how much it's weighted in this class. So 0.3529 is how much PowerSchool is weighting quizzes right now. That means towards your overall percentage, PowerSchool is giving you 32.8197 points towards your final grade. Tests multiplied by 0.4706 means that tests are adding 39.5304 points towards your final grade. And finally, assignments are only worth 17.65% because we haven't taken the final yet. So we're going to multiply by 0.1765. And assignments are contributing 16.7675 points towards your grade. And then if we add those all together, that will give us how many points total, or the percent that you currently have in this class. Or at least this fictional person. So this fictional person has an 89% in the class. Now, I always find this is a very good time to do this because I always get asked the question of, what would I need to get on the final if I want to end with an A, if I want to end with a B, if I want to end with whatever grade? This is something that you can use, especially after you take the Chapter 8 test. Go back and do this with down at the bottom here, this whole process, and it will help you figure out what you would need to get on the final. So let's say that realistically, this person wants to end the course with an A-. So they want to end with a 90%. Assuming that our current percentages don't change, so assuming that they get an 84% on the Chapter 8 test, and they get a 93% on the last quiz in Chapter 8, 8.5 through 8.6, what would they need to get on the final in order to end the course with a 90%? So our percentages for each category are going to be down here. Again, you can update your percentages and do this with your grade after you've taken the Chapter 8 test and really calculate what you think your grade should be. And we are going to walk through to see, okay, what would that do to my final grade? So we're going to take the 93 and we're going to multiply it by 0.3 because that's 30%. Plus, we're going to take the 84 and we're going to multiply it by 0.4. We're going to take the 95. We're going to multiply it by 0.15. All of those added together will give you how much you can get on, or how much your current grade is going to contribute to your final grade. But we want to know, what do I have to get on the final? So I have my grade on the final times 0.15 because it counts for 15%. And we want to know, what will it take for it to equal a 90% in the class? So 93 times 0.3 gives me 27.9 points. 84 times 0.4 gives me 33.6 points. 95 times 0.15 gives me 14.25 points. And we want to know, what do I need on the final to get a 90? So we're going to solve this equation out. We're going to add to this the 27.9, 33.6, and the 14.25. And we get 75.75 plus so now we can do 90 minus the 75.575 and divide it by 0.15. And we get that this person would have to get a 95% on the final if they wanted to get a 90% in the class. Okay, that's how weighted averages work. We take how much something is worth and we multiply it by the weight applied to it and then add them all together. And that gives you a weighted average. Let's take a look at Sarah and her predicament. Sarah has 10 pounds of dried fruit and it's selling for $6.25 per pound. She wants to know how many pounds of mixed nuts selling for $4.50 per pound she needs to make a trail mix that sells for $5 a pound. So M is going to be the amount of mixed nuts, and we're going to complete the table here. So she gets 10 pounds of dried fruit. It's $6.25 per pound. So the total price would be $6.25 times 10. Then mixed nuts. Sarah is going to get M amount of mixed nuts. M is the number of pounds of mixed nuts. It costs Sarah $4.50 per pound. So therefore 4.5 M would be the total price. Now, just like we had with the weighted averages, because really that is what this is as well. It's a weight being applied to an average. We would take and add 10 plus 10 pounds plus the amount of pounds in mixed nuts. And she wants to sell it for $5 a pound. So that should equal 5 times 10 plus M. So our rational equation is going to be 6.25 times 10 plus 4.5 M. And she wants it to be 5 times 10 plus M. So now let's solve the equation to be able to figure out what is the amount of pounds of mixed nuts that she needs. So 6.25 times 10 gives me 62.5. Whoops. Just 62 there. That's not a decimal. 62.5 plus 4.5 M equals, and distribute your 5. So I have 50 plus 5M. So I'm going to go ahead and subtract 62.5 from both sides. And I get negative 12.5. Then we're going to subtract 5M from both sides. And I get negative 0.5 m equals negative 12.5. So now we're going to divide by negative 0.5 on both sides. And I get that the number of pounds she should have of mixed nuts should be 25. Let's take a look at two more word problems. Alicia. Alicia's average speed riding her bike is 11.5 miles per hour. She takes a road trip of 40 miles. It takes her 1 hour and 20 minutes with the wind and 2 hours and 30 minutes against the wind. We need to write an expression for Alicia's time with the wind. So we're going to say that x is the speed of the wind. And if she takes a round trip of 40 miles, that means that only half of that is going to be with the wind because the other half would be against the wind. So the whole 20 miles is the distance divided by her speed. Now, without any kind of wind, she travels 11.5 miles per hour. And with the wind means that the wind is adding to her speed. So there's our expression for Alicia's time with the wind. For the expression for Alicia's time against the wind, again, she would have half of that total distance of 40 miles. So 20 miles. And against the wind would be taking her speed and subtracting off the speed of the wind. So we want to know, how long does it take for Alicia to actually complete the trip? It said that it takes her 1 hour and 20 minutes with the wind and 2 hours and 30 minutes against the wind. So we can add to that 1 hour and 20 minutes plus 2 hours and 30 minutes. Add those two together for a grand total of 3 hours and 50 minutes. Now, I would recommend changing that whole thing into hours. Okay, so I have 3 hours and then 50 minutes into hours would be 50 minutes out of 60, which is 5 out of 6. So we have 3 hours plus 5/6 of an hour. And changing that to a fraction would give us 23/6 of an hour, which I know doesn't really help things in the real world, but it's definitely a lot easier number to calculate with than having to break everything up into hours and minutes in our equations. So now we're going to use all of the information from A, B, and C to write our own equation to solve. We take the time with the wind and we add that to the time against the wind. And that should equal her total time. Now we have to actually go about the business of solving this. I probably should have written a little smaller, but we'll muddle our way through. We need to find a common denominator here. And the common denominator would be 6, because only one of them has a 6, 11.5 plus x, and 11.5 minus x. So in this first problem, or this first fraction, the 20 needs to have contributed to it. The denominator is missing a 6, and it's missing an 11.5 minus x. In the next fraction, we have a 20 in the numerator. It's missing the 6, and it's missing an 11.5 plus x. And the final fraction has a 23 on top. It has the 6, but it's missing both the 11.5 plus x and the 11.5 minus x. Now we're actually going to work through and solve this. It's just like a regular equation, no new information given. I'm going to actually switch over to paper so I have a little bit more room on here. So 20 times 6 is 120 times 11.5 minus x. And then I have 20 times 6, again, 120 times 11.5 plus x. And it equals, I'm going to go ahead and FOIL these out rather than distributing the 23 first, because you should be able to recognize that this is a factored form of difference of squares. When I FOIL this out, I will get a square term minus another perfect square. So you can draw your box over to the side if you want with the 11.5. Plus x and 11.5 minus x, but you will get that your middle term will cancel out. So 11.5 times 11.5, 132.25, negative 11.5x, positive 11.5x, and negative x squared. So I have 23 times negative x squared plus 132.25. Oops. And now I can distribute. So I'm going to distribute the 23 to both of those. I'm going to distribute the 120 to both of these. So I get 120 times 11.5. 1,380 minus 120x, 1,380 plus 120x equals negative 23x squared, and 23 times 132.25 gives me 3,041.75. All right, so now let's go about solving this. Negative 120x plus 120x, gone. 1,380 plus 1,380, 2,760. Subtract off 3,041.75. And I get negative 281.75. Now we're dividing by negative 23. So x equals 12.25. Now, since we're talking about speed here, it doesn't really make sense to put a plus or minus in front of this. So it's just 12.25 is what x squared equals. So again, when we take our square root of this, we don't need to put a plus or minus. Square root is 3.5. So it's the speed of the wind is 3.5 miles per hour. I probably should put a little bit more space in those for next time. All right, last word problem for 8.6. Last bit of notes. Oh, just kidding, there's two more word problems. Kendall and Shandi wax cars. Kendall can wax a particular car in 60 minutes and Shandi can wax the same car in 80 minutes. They plan on waxing the same car together and want to know how long it'll take. So first we need to figure out how much will Kendall actually wax in 1 minute. So she can wax in 60 minutes a whole car. So 1/60th is how much she can do in 1 minute. So in X minutes, Kendall should be able to do X times 1/60th, or X over 60. Now Shandi in 80 minutes can do one car. So 1 minute she can do 1/80th of the car. So in X minutes, Shandi should be able to do X over 80 of the car. So our rational expression, or rational equation to represent them working together on a car would be the amount that Kendall can complete in X minutes plus the amount that Shandi can complete in X minutes should equal one total car. So let's go ahead and solve this equation. In order to solve this, we're going to need to use a common denominator, least common denominator for 60 and for 80. So I would recommend writing out your prime factorization for 60 and the prime factorization for 80. So 60, we know that to be, if you did out your factor tree, 2 times 3 times 2 times 5. And 80 would be 2 times 2 times 2 times 2 times 5. And that's just a factor tree worked out, but you can always check it to make sure. So I have 2 times 3 times 2 times 5. And then 2 times 2 times 2 times 2 times 5. So our prime factorizations are correct. Sorry, that's only at the bottom of the page there. Which one has the most amount of 2's? That would be the 80. Which one has the most amount of 3's? The 60. And they both have an equal number of 5's. So our LCD that we're going to that would be on the bottom, if you really want to know what it all is together, 2 to the 4th power times 3 times 5 would be 240. So the 60 times what equals 240, or you can look back at what 60 already has. 60 has 2 2's, so it needed 2 more. So the X is going to be multiplied by 2 more 2's. It already had a 3, and it already had the 5. The 80 had all 4 of the 2's. It already had the 5, but it did not have the 3. Or you could ask yourself, 80 times what is 240? And finally, the 1 didn't have any of it. So our equation that we're solving is 4x plus 3x equals 240. 4x plus 3x gives me 7x equals 240. 240 divided by 7 gives me 34 point, we'll say round to the nearest tenth. It should take them 34.3 minutes to finish the car if they work together. Last word problem of our notes all year long. The ratio of 6 times a number and 3 less than a number is 4 to 9. Remember, ratio means divided by. So 6 times a number, 6x, divided by 3 less than a number. So x minus 3. Remember less than from the very beginning of the year. It's one of those turnaround words. So it's not 3 minus x. You have to go in reverse. X minus 3. And it says it is 4 to 9. Now this looks suspiciously like a proportion, in which case we can just cross multiply. So I have 6x times 9 equals 4 times x minus 3. You might also notice that if I had found the LCD of this, which is 9 times x minus 3, that when I'm cross multiplying, I'm only multiplying by what it's missing. It already had an x minus 3, it needed a 9. It already had a 9, it needed an x minus 3. So either way you go about this, you should still get to the same spot. So I have 54x equals 4x minus 12. Subtract 4x from both sides. So I have 50x equals negative 12. And divide by 50 on both sides. Negative 12 divided by 50. Negative 0.24, or you can give it to me as a fraction, negative 6/25.